Good afternoon. It's my pleasure to welcome you to this once-in-a-lifetime opportunity. My name is Rashid Zia, and as a Brown alum and faculty member, it's my pleasure to serve as Dean of the College. I hope you're as excited as I am for today's conversation with NASA astronaut Jessica Meir, distinguished alumna from the Brown class of 1999. This year, we are celebrating the 50th anniversary of Brown's open curriculum. Our distinctive, student-centered, purpose-driven approach to undergraduate education. As members of the Brown community, you in this room and watching on live stream know that the open curriculum is defined by exploration and collaboration. It is a recognition that to advance the frontiers of knowledge requires moving beyond boundaries and working together to support shared learning. A recognition that education is about the relationship between students and faculty and the shared discoveries that we can all make together as learners and teachers. Today, we will be hearing from two distinguished alumni who embody these principles. Two alumni who have built upon the close relationships they developed on this campus and elsewhere to become leaders at the frontiers of human exploration. Professor James Head is the Lewis and Elizabeth Shirk Distinguished Professor of Geological Sciences. He earned his doctorate from Brown in 1969, during the very month that the open curriculum was ratified. And perhaps not coincidentally, given his work at NASA, just 2 months before the first human walked on the moon. Before returning to join the faculty at Brown in 1973, Jim worked with the NASA Apollo program, where he analyzed potential lunar landing sites, studied returned lunar samples, and provided training for the Apollo astronauts. Please join me in welcoming Professor Head to the stage.
Rashid asked me to essentially explain in my own words how the open curriculum led Brown University into space exploration and beyond. And I'm really happy to do that today. It's almost like my life flashing before my eyes, actually, because I've been here for almost all of these 50 years. So today we're celebrating the 50th anniversary of the open curriculum, and one of its wonderful outcomes, an interview with NASA astronaut Jessica Meir, Brown class of '99. From the International Space Station, okay? She is in a scientific laboratory orbiting Earth about 250 miles above your head. And I think we can look upon today as another first for the open curriculum, a group independent study project from space, okay? So this is gonna be good. So my perspective on the 50th anniversary of the open curriculum really derives from being a student at Brown who was significantly influenced by the tumultuous years leading up to the open curriculum and as a Brown professor in the years that followed. I arrived at Brown in 1964, coming from Washington Lee University, a small liberal arts college in Virginia that had about 1,200 students, and it also featured very significant student-faculty interactions. I fell in love with geology my freshman year. The labs were outdoors, go figure, okay? Be in a stinky chem lab or be outdoors. So I became a geologist really quickly and worked with my professors every summer doing geological exploration and mapping in the Appalachian Mountains. I entered graduate school at Brown University in the fall of 1964, essentially intent on gaining a graduate degree in geology and probably teaching at a small liberal arts college in the Appalachian Mountains in Virginia or elsewhere. These were incredibly tumultuous years. It's really hard for most of us in this room to think about the events that were happening at that time. The assassination of President Kennedy, the civil rights movement, the assassination of Martin Luther King, riots and near revolutions in the inner cities, the war in Vietnam, Cambodia, and Laos, resistance to the military draft, and student-led protests, strikes, and general unrest on college campuses. This period in my life entered a sort of schizophrenia that I came to know well. On the one hand, I followed my passion for geology with persistence and total excitement. On the other hand, I strived to discuss and understand with the Brown faculty and my fellow students the seemingly random, capricious, and xenophobic actions that were at the root of the continuing and intense crises at home and abroad. In response to the escalating and expanding war in Vietnam and Southeast Asia, Brown faculty and students organized together teach-ins This sounds so archaic now, but we spent many, many weekends and evenings doing reading and other kinds of things. We read books on the history of Southeast Asia. We heard talks from some of the major players in the ongoing struggle, both civil rights and the war. Martin Luther King, Ambassador to Japan Edwin Reischauer, the chairman of the Joint Chiefs of Staff, and many, many others were brought to campus by the faculty to discuss these things with the students and the faculty. It was an incredible environment at Brown. We became mutually educated on the national and international issues through learning, critical thinking, and debate, and sometimes raucous demonstrations. One of my fellow graduate students, David Schwartzman, was arrested for trying to come up on the stage to present to the chairman of the Joint Chiefs of Staff a petition signed by the students to end the war. We also began to critically assess the modes of teaching and the framework of education at Brown and on other college campuses and on the national scene. What were distribution requirements doing to inhibit our understanding of critical and immediate national and international issues? Why couldn't we have a curriculum that reflected the issues at hand and that was as flexible and educational as the teachings that we were engaged in actively at that time, in which students and faculty were currently really, really fundamentally engaged together? And the faculty. As students, we discovered a diversity and depth of talent in our faculty members that went way beyond essentially their traditional fields of expertise. Why weren't we taking advantage of these in their teaching duties? Thus was sown the seeds of the open curriculum. Modes of thought courses, individual and group independent study courses, elimination of distribution requirements, designing your own concentration, and much, much more. At the same time, my graduate studies in geology and stratigraphy continued unabated with passion and excitement. It was a great time. Midway through my graduate career at Brown, I fell under the spell of Professor Tim Much, a tall, lanky explorer, mountain climber, visionary, who was a well-established national figure in reading the record of the sedimentary rocks on the Earth from the nature of it, and this is a field known as stratigraphy, and we fell under his spell and became Earth stratigraphers. Tim was so tall that we students felt like he was the only one who could see over the horizon and into the future. This is just amazing. In the third year of my PhD studies in 1966, 3 of us enrolled in Tim Much's Advanced Stratigraphy Seminar. This was a graduate course in the emerging research problems that were to form the basis of our research in our early post-PhD years. So this is going to outline what are you going to be working on for the next decade and beyond from your basic education. One day early in the semester, in the middle of a lecture, Tim walked over to the window in Rhode Island Hall, gazed silently out the window for several minutes, and then abruptly turned around to us and announced, "You know, there are just no fundamental problems left in Earth stratigraphy." Oh my God, we were stunned. 1 year from obtaining our PhD thesis, and there are no fundamental problems left in the field that we're going out to the world? I mean, how can this be? Before we could even recover from the shock, Tim further announced, "Why don't we just take the tools of the electromagnetic spectrum," which none of us had ever heard of, "see how they can be applied to Earth, and then apply them to the stratigraphy of the planets, you know, the moon, Mars, and beyond." This is in 1967-68. Needless to say, we went from being stunned to being flabbergasted. The stratigraphy of the moon and Mars, are you crazy? We didn't actually say the crazy part, but we really thought it, okay. So the bottom line was that we actually went on, and we probably, this might have been, in fact, the first group independent study project on record for the new curriculum. We went along with Tim on this seemingly dead-end direction, and we learned a huge amount that was not at all part of the traditional curriculum. The course significantly changed our way of thinking and approaching problems and taught us new techniques that we had never even thought about or even applied before or had been applied to these problems before. Most importantly, it taught us to do what later became known as thinking outside the box. During my last year of graduate school, 1967-68, Tim went off to Arizona on sabbatical, pretty much leaving us graduate students on our own. About this time, I'm thinking about casting about for a job. I was thinking about going into the oil industry or maybe into some small teaching position in a small college, et cetera, when I came across a document called the College Placement Manual, pictured here. This is basically a book of jobs. I turned to the index and looked up geology, and saw listed page 16 to 22. This is where the advertisement for geologist jobs would be. And page 47, 16 to 22 and 47. I thought, what was this outlier on page 47? Why wasn't this listed with the other geology jobs on page 16 to 22? I turned to page 47, and my eyes fell on a full-page ad with a picture of the moon and the words, "Our job is to think our way to the moon and back." I thought, oh my God, how do you do that? How do you do that? Well, there was a phone number in the lower left-hand corner of the ad. I called it immediately. It was NASA headquarters. They were going to the moon, and they needed geologists. I got the job. I actually never looked at pages 16 to 22. In the summer of 1968, I reported to NASA headquarters in Washington, D.C., and began my job as a systems engineer. I'd never had a course in engineering. I didn't even know what a systems engineer was, but I was one, and we were going to go to the moon. But it quickly became clear that systems engineering was simply thinking your way to the moon and back. From Apollo 11 to Apollo 17, I worked in mission control during the missions. I worked on landing site selection, training the astronauts in geology. Most of them were test pilots. They were such great students, unbelievable students. Mission planning, mission operations, and mission control during a mission, and debriefing the astronauts when they got back from the moon. I continued to work on astronaut training in Houston for every new astronaut class since Apollo. They're just great people, including the one we're going to hear from this afternoon. Sometimes we even brought them to Brown for their training. Following the Apollo program, Tim Much invited me to apply for a faculty job at Brown to help build his nascent planetary geosciences program. Taking full advantage of the opportunities enabled by the new curriculum, the open curriculum, we taught modes of thought courses in exploration and Earth, Moon, and Mars, and built an undergraduate and graduate program in the geology of the planets. We learned how the planets informed us of the missing chapters of Earth history. Tim, an engineering professor, Bill Patterson, supervised and built the first cameras that made their way to the surface of Mars on the Viking missions in 1976. Dozens of undergraduates and graduate students in planetary geoscience from Brown University essentially have gone on to careers and leadership positions in planetary science at NASA and other NASA centers and throughout the world, in universities and in industry. Two, you can see here illustrated, by the way, dozens of different missions that have happened in that intervening period. Absolutely fantastic. Two of these students, Ellen Stofan and Jim Garvin, became NASA chief scientists. And Ellen Stofan today is the director of the Smithsonian National Air and Space Museum. The Modes of Thought course entitled Earth, Moon, and Mars became Geo5, a popular science course option for inquisitive students of all backgrounds, from, like I like to say, from freshman poets to senior physics majors. Today the course is taught by Jack Mustard, and he's doing a great job on this. It's absolutely fantastic. But when I walk into the classroom on the first day of class, I know that thanks to the open curriculum, the students are in there essentially because they choose to be there, not because they have to be there to fulfill a distribution requirement. During the more than 40 years that I taught Earth, Moon, and Mars, over 4,000 very bright and highly motivated Brown students participated. It was just absolutely amazing. Okay. What we would do is bring Apollo astronauts, for example, to the classroom. Here's a picture of Dave Scott, the Apollo 15 commander. Here's Dave on the moon. Here's Dave in our lab. And here's Dave in the classroom in Geo 50. They would tell us about their perilous journeys to the moon and the scientific discoveries that they made. In 1998, one of these bright and highly motivated Brown students, Jessica Meir, enrolled in Geo 5 and ended up receiving the highest grade ever in my class. No surprise there. Jessica had been guided to the class on the basis of her interest in space and her childhood dream of becoming a NASA astronaut. She had written to Apollo 16 astronaut Charlie Duke to ask advice on what she could do in order to become part of the astronaut program. In a letter to Jessica, which Jessica shared with me a couple of years later, Apollo astronaut Charlie Duke advised her on how to contact NASA and suggested that because I was one of the teachers of the Apollo astronauts, she should seek me out at Brown to learn more about space exploration and indeed the NASA program. And indeed she did, beginning a long-term friendship that continues to this day. She was a Space Grant Fellow with Professor Pete Schultz flying in the Vomit Comet, and she participated with us in a briefing to the legendary NASA astronaut John Glenn when he came to visit Brown. In 2019, Jessica was chosen to be a NASA astronaut as part of the 21st astronaut class. These were known affectionately as the 8 balls for a variety of reasons. There are 8 of them and some other things. The previous class names the subsequent class, and there's a lot of history there, which I won't go into. Buy me a beer sometime, I'll tell you all about it. In any case, she and her colleague here, Christina Cook, were the ones that went on to become the first all-female spacewalk, which we'll talk about in a brief second here. So Jessica was part of this class. It's a great class, unbelievably good class. They all are, but this was, to me, exceptional, not just because Jessica was in there. Jessica launched to the International Space Station on the 25th of September last year. And here you can see Jessica's launch. Here's the space station. In this space station, Christina Cook, her crewmate, was there taking pictures. This is Jessica lifting off. You can see the contrails. That's the rocket on the way to the space station. It's like a stunning, stunning image. Jessica is currently working with her international astronaut crewmates on scientific experiments in orbit, and this is her view down on the orbit, from orbit down on us. This is southern New England here. You can see Boston. Well, that's not so important, but here's Providence over here. Okay. And you can see the aurora. Look at this. Here's sunrise over here. Here's a part of the space station. This is where we live right here, and this is and here is where we'll hear Jessica from. Jessica is currently working with her colleagues on the space station on scientific experiments in orbit, and with her crewmate Christina Cook, she recently completed the second all-woman spacewalk in history. A week ago today, Christina came back to Earth, very happy, as you can see, and indeed, Jessica remains in the International Space Station with her colleagues doing very, very significant scientific research, which I hope we'll hear a little more about today in the question and answer period.
Please join me in welcoming the president of Brown University, Christina Paxson.
There she is! Woo! Jessica, can you hear us?
Hello, everybody.
Hi.
I can hear you loud and clear, President Paxson.
Thank you.
Hello, everybody at Brown.
Welcome. Woo! So, Jessica, I know that we can see you. You can't see us. I am looking out in the big room in Solomon at a very large number of very excited Brown students and faculty who are so eager to talk to you. So I just want to welcome you and hope you're doing well. Everything good?
Thank you so much, President Paxson, and all of you. Everything is wonderful. It's difficult for me to wipe this constant grin off my face. It's really been here pretty much since the end of September since I arrived. As you can imagine, it's really a dream come true.
Terrific. I am going to invite Rashid Zia up to the stage, and we're going to start a Q&A. Everybody is so excited to talk with you, and we'll go from there. But just we're all so proud of you. Yeah?
Thank you so much. Well, it really do owe a lot of it to the foundations and education that I received right there at Brown, so I'm happy to be able to share this adventure with you.
Great. Let's give Jessica a really big hand.
Hi.
Rashid.
Hi, Jessica. This is Rashid Zia. I think we might have taken biology classes in this room together when we were both students. We have some questions for you, so we'll let the speakers come up.
Hello from Brown University, Jessica. I'm Mary Wright, and I direct the Sheridan Center for Teaching and Learning. In 5th grade, my teacher asked me, if given the choice, would I prefer to travel around the world or go to space? And I chose travel around the world, which she was very disappointed in my answer. But since you are in the enviable position of having done both, why might I have considered space?
Well, they're both pretty amazing things that anyone would be very fortunate if they get to do. I think choosing space actually combines both of them because I am looking down at our amazing, magnificent planet Earth anytime I have a chance, and we are going around that planet every 90 minutes. So I guess up here in space, you're actually doing both at the same time. You're traveling around the world many times per day, and you're in space.
Thank you.
Hello, my name is Calder, and I'm a 6th grader at the Gordon School. And in a different interview, you said that the veins and arteries age faster in space than on Earth, and I want to know why.
Well, that is exactly why we're doing experiments to try to understand that process more. We do need to figure out why these things are happening and how we might prevent them if we're having deleterious consequences to our health, for two main reasons: to make sure that as astronauts we can come home safely, and then when we explore further, for example, when we go back to the moon and go to Mars, we need to make sure that we're keeping astronauts healthy for their missions there. And we actually don't know the answer yet. That study is still ongoing, and we'll have to wait and see what the scientists find and what they eventually publish. But some of the things that are hypotheses are things like the effects of radiation. The dose of radiation that we receive up here is higher than when we're on the surface of the Earth, since we're not protected by the atmosphere. And we have other variables as well. The fluid shift that we experience, when you're on the ground, the gravity is always pulling your blood and body fluids down towards your feet. When you come up here, everything shifts up and you get some higher pressures in the upper part of your body. And then you have some differences in the blood flow to your brain and to your head as well. We get kind of this congested feeling in your head. So the heart is, of course, working differently when it's in gravity or when it's not working against gravity like it is up here. So all of those things may play a role, but you'll have to stay tuned and find out what this experiment results.
Cool, thank you.
Hi, it's weird, I can't see you. I'm Ainsley, and I'm a first year, and I'm an aspiring astronaut as well. I wanted to ask, since you're living the life I want to be living, when you were living my life as a freshman at Brown, what were you thinking about? And did you ever think you could make it to where you are now?
Well, I was already thinking about space. I wanted to be an astronaut from the time that I was 5. So when I was at Brown and at other times in my life, I tried to involve myself in as many space-related activities as possible. While I was at Brown, I did a summer program called the Space and Life Sciences Training Program, one of the summers in between sessions at Brown. And this was something that was put on at the NASA Kennedy Space Center. And it was specifically for space biology, so really delving into all aspects of space biology. I was in the Brown Space Club. I also designed an experiment with some other students to have a flight on it was called the Reduced Gravity Student Flight Opportunities back then. But if you've ever heard of the Vomit Comet, the airplane that NASA had, actually, we no longer are operating it, flies in parabolas. So essentially you get about 30 to 35 seconds of weightlessness. And while I was at Brown, we actually designed an experiment to conduct, and actually got to go down to NASA Johnson Space Center and conduct that experiment. And of course, even though I was majored in biology, I really wanted to take Professor Head's planetary geology course because I was such a space geek. So, and that started the friendship and colleagueship that I have with Professor Head there too, and a lot of exciting prospects with research and even into our astronaut training and our astronaut candidate training program. So that was the main answer. I was really trying to involve myself in everything possible that I could get my hands on. I knew I always wanted to be an astronaut, but I didn't think it was necessarily going to come true. We all know there's such a small chance of it happening for anybody, no matter how qualified you are. There's a lot of luck involved because there are a lot of other people that are equally as qualified and deserve to be here too, but unfortunately, it's a lot of luck and numbers game in the end.
Hello, my name is Nick Conroy, and I am a senior studying physics and history of science. I have a bit of a similar question. So do you have any advice for seniors interested in the field of aerospace and astrophysics? And if so, was there anything specific you did either as an undergrad or just after graduation that helped you work at NASA? And then is there anything you wish you had done differently?
It's a lot of questions. I think the main thing is to really use the resources you have to find out what is out there. I think that was one of the things, when I was at Brown, it was quite a while ago, so we didn't have quite the ease of having all of the resources out there. They're much more easily obtainable now with all of the aspects of social media and the internet. And so I think it's important to make sure that you're really doing your homework. You're really investigating and finding out all the different possibilities and choosing the ones that seem to resonate with you the most. You have to make sure that you are being passionate and following what it is that makes you passionate, because I think that's really the only way to excel in it. I tried to find out about all these other opportunities, like I was just mentioning, that were space related or that NASA had, and there really are a lot of opportunities out there, including ones that are funded and provide funding. So they really make themselves available for people from all backgrounds and from all resource levels. So I would encourage you to just reach out and find out which opportunities are there and make the most sense for you, and just work hard at pursuing them. You have to be able to be willing to take a risk, because I think without that, you really won't be able to achieve what it is you really want to do.
Thank you.
Hi, Jessica. I'm Sinead Gallivan. I'm a planner in the Office of Planning, Design, and Construction at Brown. My question for you is this. Was there a pivotal moment in your life and career where you had to make a difficult decision and take a leap that you believe led you to be a part of the first all-female spacewalk and a part of this space expedition?
I think one example of that is when I applied to be an astronaut for the class that I was selected in. And I had applied before. As soon as I met the basic requirements, I started applying. And once I was realistically competitive was when I was in graduate school. And I applied, that was in the 2008 2009 period for the 2009 class. I made it to the final round that year, the final 40 to 50 people, and everything went really well. But I didn't get selected that time. And I got the call that said, great job. We liked having you down here. It was great to see you again, and we encourage you to apply again, but we only chose 9 astronauts, and you're not one of them. And that was a really difficult moment for me, even though, as I mentioned, I never thought that it would necessarily come true. I knew it was such a small chance. To have come so close and then to have that result was, of course, it took a toll psychologically and mentally, as did that whole process. It was quite drawn out for the selection. So when the time came to apply again in 2013 for the 2013 class, I was actually doing something else. I was working I was doing my postdoc, actually. I was working as a comparative physiologist, doing research with animals in extreme environments, and it was something else that I found extremely fulfilling. I felt so fortunate to have found another career that really resonated with me and meant something to me, and that I knew that I could be happy in. So when the time came to apply again, I actually thought, well, do I want to put myself through that again, that mental and psychological toll and this long process, when I'm sure it's just going to be the same result? I won't get selected, and I'm already happy. Maybe it will be better for me to just stay in academia in this career that I'm in anyway. And so I had that thought, but then I realized that if I didn't at least apply, I would always question it. I would always look back and wonder why, if I could have actually fulfilled this childhood dream. But it was a decision that I had to make, to do that, to take that risk, to not be afraid to fail again. And because I did that, that's really the only reason why I ended up here today. If you don't try, then of course it's not going to happen.
Thanks so much.
Hi, Jessica. My name is Jennifer. I'm a senior studying biology and Slavic studies, and I work as a peer advisor at the Office of International Programs. And I know you studied abroad in Sweden and you trained in Russia for your current mission, so I just wanted to ask how your time studying abroad impacted your life after Brown, and if you would recommend it to students.
I definitely recommend that opportunity to anybody who is interested in it or can make it work with their schedule. It was such a valuable experience for me, living and working with other cultures, and I think it's very important, really, in multifaceted ways. One, to just make you a more well-rounded, understanding person and citizen of the world, because we really are in this together, and that's really apparent and easy for me to see when I look down on the Earth and I see it in its entirety, how fragile it is and how it has actually really no borders. Everyone is there. We are all in this together. I think that's really important to appreciate, to understand, and to open your mind and appreciate other cultures and experiences. And it's something that certainly benefits me up here on the International Space Station. We have an international crew. We have our Russian counterparts, our Japanese, European, and Canadian counterparts as well. And we're all up here working together. And I think that some of those experiences that I gained from studying abroad really helped me integrate well and have that full understanding of what it's like and how to succeed in working in an international group.
Our next question was submitted by a Brown alum for our original Alumni Weekend event in October. Timmy Jang, a class of 2018 alum who double concentrated in public health and biology, wrote, "Hi Jessica, I recently finished my fall internship at NASA's Human Research Program at the Johnson Space Center. The H3PO lab says hi. How do you see the role of international diplomacy panning out as NASA prepares for Artemis 2024 and China entering the space exploration landscape?"
Yeah, obviously this is a very important part of everything that we do, thinking about the political impact in international diplomacy. NASA is a government agency. Its budget is, of course, only approved by Congress, and the administration is in charge of determining where it is that we go next. I do truly believe that when we do make that next great step, when we go back to the moon, when we go to Mars, we will be doing so. We already know and have demonstrated with partnerships that we will be doing this at an international level. The space station is a great example of that. It is such a shining star showing how we can work together whenever we put our minds to something, despite the political situations that might be apparent on Earth. And that's something that meant a lot to me as I lived and trained and worked with my Russian colleagues, of course, in the last couple of years. It's a great example, I think, to show what we can do up here together, despite everything that's going on the planet. And I think in order to really pull off something great like getting to the surface of Mars, it is going to be something that we can't do alone as any one nation. Given the budget that it requires and given the expertise required, I simply think that we will be more successful and have a better team if we all go together.
Thank you.
Hi, Jessica. My name's Ashley Palumbo. I'm a fifth-year PhD student here studying planetary science with Jim Head and a NASA fellow. My question for you is this. The first all-female spacewalk was such an exciting historical event for our generation. And as we look forward to Artemis, we're excited for another historical event, which is, of course, the first woman and the next man on the moon. How do you think your time on the ISS has prepared you to potentially be one of the first women on the moon?
Well, all of the training that we receive as astronauts at NASA and everything that we do up here is really honing those skills and all of the things that are very important to succeeding as a team. The technical skills that we learn when training on the ground, really all the people on the ground training us are the experts. We are up here and we are executing everything only because we were trained so well, and the experts on the ground are guiding us through all the time, the whole way. So I think that everything we do up here, living and working in isolation in a confined environment, getting along with a diverse crew and for a long duration mission, all of these things will be very valuable when we make those next steps in going toward the moon. Just like anything else, every experience is worth so much. And so just the experience of everything that I've accomplished and done in this mission with my crewmates will really help prepare us for those next steps. And if I'm lucky enough to be part of that mission, I hopefully will be able to contribute all of the lessons that I've learned up here and help that make that mission even more successful.
Thank you.
Hi, Jessica. This is Rashid again. Last fall, many of us gathered together to watch as you and Christina Cook led the first all-woman spacewalk. In November, you and Christina wrote an opinion piece in the Washington Post about the experience where you said, quote, "The real achievement is the collective acknowledgement that it is no longer okay to move forward without everyone moving together." Could you please share with us the importance of diversity and inclusion to NASA's mission and the future of scientific exploration broadly?
It's a very important point. I know it's something that we believe in very strongly at Brown, and it is something that is a core value at NASA as well. Just like any other entity or agency, NASA is a government agency in this case, we really need to make sure that what we are doing as we are moving forward in the future is a reflection of our society, a reflection of all of humankind. We often are the face, as astronauts, we are the face representing that, and we need to make sure that we are representing everyone. It's exactly like the words that you used from our Washington Post piece. It really, I think, the greatest achievement was not only overcoming the history of the first all-female spacewalk, but of people recognizing that it is no longer okay to make those steps if there's just a few people being represented. And when we make those next bold steps, we will be doing that with everybody. That is certainly something that that resonates in NASA's core mission objectives, in how we select and train our workforce and our astronauts. And I think that it is truly a reassuring fact to see that our world is really improving in that regard and getting day by day getting better and better with leaps and bounds.
Thank you.
Hi, Jessica. I'm Tycho, a senior studying astrophysics. My question is, how did you mentally prepare before, and how have you mentally prepared during your space mission?
Yeah, mental and psychological aspects of the mission are very important. And I think the first step of preparation is the selection that we undergo as astronauts. Psychological evaluation and consideration are very important in selecting our astronauts. Now so even more than before, in that we're really looking at astronauts for these long duration missions, since that's the real nature of our human spaceflight program right now. And so it doesn't really matter, now at NASA, if you're just the hotshot pilot or the best at what you do, it doesn't matter if you're not also a good person. I like to think of it as the kind of person that you'd want to bring on a camping trip. You need to make sure that you can take care of your own things, but you can also be a team player, take care of yourself as well as take care of the team. We emphasize things like leadership and followership as being all very vital aspects of what it takes to be successful working up here together.
Thank you.
We have an audience question from an alum. What are the teamwork fundamentals most important for space living?
Yeah, so I kind of am wrapping up. I think that's similar to what I was just saying with the last question. And, in addition with that last question is the psychological support that we receive from the ground. We have a whole group that supports everything that we do up here, making sure that we maintain our psychological and mental well-being. We maintain contact with our loved ones back on Earth, and they send us care packages, things like that help get us through when we're missing the people back home. As far as the fundamentals, I think the things that I mentioned, followership and leadership as well as followership, equally as important. One of the things that is interesting about our job is that we're constantly shifting leadership and followership roles, and that's sometimes not as simple as you might expect. And those team care, what we call these expeditionary skills, as I mentioned, taking care of yourself, but also contributing to the team, and communication being probably the most important area. Understanding that people work differently, there are individual differences, and being able to appreciate those and utilize everybody's different strengths, recognize and understand your own weaknesses and what you can bring to the table, and making sure that you can communicate with those around you. And that is something that is difficult when you're living in isolation for 6 months in a small area with the same people. But as long as you're communicating effectively, I think that has what led us, I know that's what has led us as this crew to have a successful mission.
Thank you.
Hello, Jessica. My name is Bella. I'm a fourth-year dual degree student majoring in illustration at RISD and concentrating in anthropology at Brown. And my question is, what is the most visually surprising thing that you have observed from this experience due to the distance from which you can observe the planet?
That's a very difficult one to answer because almost every time I go into the cupola, which is our primary area where all the windows are around us and also looking straight down, I'm astounded at the things that I see. I remember one of my first impressions was how the atmosphere looked, and I think it's difficult to capture in a photograph, but from up here you can really see with your eyes the changing gradient of the atmosphere. First of all, the most remarkable thing is how thin it is and how it makes you realize how important it is that we protect it. But then you can actually see as a whole hues and a gradient of different blues. You can see how the air is getting thinner and thinner and thinner with altitude until it fades out into the blackness of space. And one of the really surprising things that I saw was the first time I saw the night sky from space. So you're looking down and you can see all the city lights, of course. You can still see the atmosphere even in the dark, and it's not blue, but it looks like this burnt orange color. And I think just because of the wavelengths, it looks even thicker than it does during the daytime when it's blue. But it's this phenomenal color. And I'll never forget one of my first passes in the cupola. We flew up the northeast of the U.S. and we flew over New York City. You could see all four corners of Central Park. We crossed the Atlantic in the sunset. I saw my first sunset from space. And then we came over Europe and I could see all of the lights of France and lights of the UK, and suddenly I saw the most amazing aurora that I have still seen since I've been up here. And we could see the northern lights all across Europe, and it's this very otherworldly effect of this dancing green in all directions, and it is truly just phenomenal. So I could go on and on and on about all the different things that I've seen up here, and each time it's just simply astounding how special and beautiful our planet and really all of the other objects in the solar system are.
Thank you.
Hi, Jessica. Thank you. My name is Dana. I'm a sophomore here studying environmental science, and I'd like to ask if being in the ISS makes you think any differently about how finite our world is, and if you feel any differently about climate change.
Yeah, I think when you look back at the Earth for the first time, with your own eyes, to me, this was something I thought about a lot before coming up here too, and it really has rung true. I think for most people, it brings up two main points. One, looking down at this fragile blue ball below you, and you're thinking about how everyone that you know, every place you've ever been, everything in the entirety of your life and in the whole evolution of the human species is down there in this one beautiful, magnificent ball. And you realize how special and unique that is and how we really need to do our best to protect that, the oceans, the land, this very thin atmosphere that you can see. Climate change and our effect as man on the Earth's climate and habitability were something that's very important to me even before becoming an astronaut. But it's, I think, for some people that hadn't thought that much about those aspects, when they look back at the planet for the first time, they have a much deeper appreciation for it. And the second area is really thinking and realizing how insignificant we are as humans, what a very, very small role we play in the solar system and in the universe. And that's much easier to appreciate from up here when you're looking down on it. I think it's very important and humbling for people to gain that perspective. It's so easy on Earth to get caught up into really trivial matters that really aren't very important. And I think it's always important to take that step back and gain that big picture.
Thank you.
Hi, my name is Leela, and I'm a sophomore studying physics. My question is, are there any questions you wish journalists, students, and other members of the public would ask you more often?
Yeah, as you might imagine, we get asked the same questions quite often. And so sometimes you really just want to be asked something totally different because you get used to saying the same thing over and over again. And, it kind of just becomes, you feel like maybe a bit of a broken record. But it's interesting, when I start talking about my experiences up here or in my job as an astronaut, I think just because it was something that I always wanted to do, you can actually still see the enthusiasm. I hope you can still see the enthusiasm in my answers. But as a scientist, of course, I always hope that we get asked more of these geeky science questions. It's so interesting for me to be involved in this whole array of impressive science that we have going on up here, ranging from physiology and medicine to combustion experiments, biotechnology, protein crystals growth, you name it, any type of experiment we're doing up here. And when you think of this as a scientist, when you've removed this ever-present variable of gravity that has always been an impact, had an influence on any experimental design on the Earth, the possibilities it really opens are endless. So I would love to talk more about that.
Hi Jessica, my name is Katie, and exercise and sports are very important to me. How do you stay fit in space? Does the lack of gravity affect your fitness?
Yes, absolutely. And exercise and sports are very important to me as well. And they're even more important to us as astronauts when we come up here, because without the loading effects on our bone and muscles, the loading effects of gravity that you're experiencing right now on Earth, even if you're not exercising, if you're just sitting there, your bones and muscles are reacting to that force of gravity. And that loading force is keeping your bones and muscles healthy. So when we come up here to space, our bones actually start leaching calcium immediately. And without doing something to counteract that, we would have a significant decrease in our bone density, and also our muscles that we weren't using would begin to waste away, to atrophy. So we exercise every day up here on the space station. We have 2.5 hours of exercise built into our schedule. We lift weights every day with this very impressive system called ARED, the Advanced Resistive Exercise Device, and we can arrange it into all of these different orientations to do, like maybe I think about over 25 different exercises, everything you would do in a gym, like a squat and a bench press and a deadlift. And then we also have a treadmill so that we can run for our cardiovascular fitness. And then we also have a cycle ergometer, a stationary bike. So we do weightlifting and then either the treadmill or the bicycle every day in order to prevent that bone loss and muscle atrophy. And it actually is very, very effective because we have this amazing equipment on board the space station now. We sometimes come back with higher muscle mass than we had going up. Maybe that's also because we're not spending much time just sitting on the couch watching movies. And we also are able to maintain our bone density in most cases. So it is really promising, and it shows you how important exercise is to our healthy lifestyle.
Thank you.
Thank you so much, Jessica. We're inviting up all of the questioners so we can take one photo with you before we say goodbye. So please, all the questioners, come up. Thank you so much for joining us. It's really been thrilling, and we hope to see you back on campus soon.
It has really been wonderful speaking to you. I had such a wonderful experience at Brown, and I can't wait to get back there again and to see everybody. I hope that I'm successful in sharing this adventure with as many Brown alum and students and anyone, and really with everyone down on the Earth.
Thank you so much. Hope you have a wonderful mission.
Thank you, everybody.